class, welcome to our 2.5 scale factor notes. Let's go ahead and get started. We'll start with a percent recap. Remember that when finding a percentage of a number, you can essentially solve like this. First thing we're going to do is we're going to change our percent to a decimal by moving the decimal place over to the left 2 times. So 40% of 30 is the same thing as writing 0.4 times 30. Okay? And when we multiply that, our answer is going to be 12. I want you to solve B, C, and D in the same exact way that I did this. And when you're finished, please get it checked by me. And then we'll get started with the rest. Now that we're caught up on percents, let's talk about scales. First thing you need to know is that scales are used to enlarge or decrease the size of something. We can see scales being used in real life when we look at maps, things like Instagram, blueprints, recipes, TV, and things like that. If you think about social media, when you're looking at a picture, the size of the picture is not the actual size of the person or object that is pictured. So, app makers and creators have to scale down the images so that they can fit on your device. Likewise, when we look at maps or GPS systems, they are not always the exact size of the location, but they are a scaled down version of the location so that they can fit on our device. A scale is the relationship between the measurements on a drawing or model and the measurements of the actual real-life object. So as I stated before, an example of that would be a map. If we look at this map that's pictured, we can see streets and we can see buildings. But we know that in real life, these buildings would not even be able to fit on this page, let alone in this room that we're in. So we use maps in order to kind of scale down and put everything kind of where it needs to be. But we use another measurement for the drawing in order to articulate what it would look like in real life. So here you can write that a scale is the ratio of a given length on a drawing or model to its corresponding actual lengths. And we're going to write that again kind of in another way. A scale factor is the ratio of two corresponding sides of two similar figures. Now, let's look at this example. Here we have a square that has 1-inch sides, and we have another square that has 5-inch sides. These are two similar figures because they are both squares. And I'm going to go ahead and put my right angles in here as well. Okay? If I wanted to find the scale factor of these two squares, I could say that the scale factor is 5 to 1, or 5 inches to 1 inch. And we can look at that as being 5 inches over 1 inches. Okay? Now, with all scale factor problems, you're not going to always be given a picture. So just be aware of that. Also, in other instances, the problem may even give you the scale factor and ask you to solve for a missing side. So we're going to look at some problems that look just like that now. The first problem that we see, example 1, says a scale of a map is 2 centimeters to 25 miles. That's important. What that means is the map is showing in centimeters, but the centimeters actually represent miles. So for every 2 centimeters, that actually represents 25 miles. The question says use proportions to find the actual distance in miles for 12 centimeters on the map. Well, if we know anything about proportions, we know that a proportion is when we have two rates or two fractions that are essentially equivalent. So I'm going to set up my first ratio by setting up the scale. The scale is 2 centimeters over 25 miles. Okay? Now I'm going to set that up equal to what the problem asked me to find the actual distance in miles. So I need to find the distance in miles. That means when I write my second fraction, miles, if it's asking me to find it, that means I don't have it. So that means I can represent what I don't have with the variable x for 12 centimeters on the map. So now I have 25 centimeters over 25 miles equals 15 centimeters over x. And I'm trying to solve for x. Now this may look familiar to you, and it is familiar because we've done this before. Now we're going to use the crisscross method, and we're going to cross multiply to solve for x, same as we've done before. So we're going to bring down our equal signs once we do that. On this side, we're going to write 2 centimeters times x equals 25 miles times 12 centimeters. And the only thing I did there was take what was crisscrossed together and multiply it on either side of the equal sign. Okay? 2 times x is the same thing as 2x equals 25 times 12, which is 300. Okay? Now my final step is to solve for x. And since I have to get x by itself, and this is 2 times x, I need to divide both sides by 2, which is going to give me with 1 on this side. So I'm going to bring down x, and 300 divided by 2 is going to be 150 miles. Now please keep in mind that this problem is incomplete if you do not include your units. So please make sure that you do that. Okay? Let's try the second problem. Ms. Fersner drew a scale drawing of her classroom. If 3 centimeters on the drawing equals 6 feet, that's a scale. Hint, hint, wink, wink. What is the real length in feet of wall AB? Okay, so if we look at this picture that's associated with this, we know that wall AB is 12 centimeters. But the first thing I'm going to do is set up my actual scale. My scale is that 3 centimeters is the same thing as 6 feet. Okay? Now I'm asked what is the real length in feet of wall AB. Okay? So I know that wall AB is 12 centimeters. But I want to find out what its length in feet is. And the only way I can do that is by setting up this scale proportion and solving for x. That's going to give me the feet that I need. So I'm going to do the same thing. Cross multiply and solve for x. Once you have finished solving for x, I want you to get this checked by me. And then you can proceed to the back. Now that you've made it to the back, I want you to take some time and solve this problem. The scale factor has been given, and you are going to be asked to solve for a side. So make sure that you show all of your work, reference some of the problems on the front. Once you finish that, we can move to the bottom, where you're going to be asked to create a second scale drawing of one of the figures. Now, I'm going to demonstrate this with figure A and let you do figure B by yourself. So this scale drawing says, this problem says select a scale, create a second scale drawing of the figures below using a scale of 3. So when we see that the scale is 3, that means that whatever this is, we need to blow up 3 times. Okay? So here's what that looks like. The first thing I'm going to do is I'm going to count my units and see how long this figure is or how large this figure is. Okay? 1, 2, 3. I know that this is 3 units. Okay? It's 3 units here. And it's essentially it's a square because it's 3 units all the way around. Okay? So in order to do the math behind this, the first thing I'm going to do is understand that the units that I'm working with here are 3. So if I set this up and identify that my original, I'm going to have to multiply or blow up times 3, then I know that 3 times 3 equals 9. Okay? So what that means is now that I'm getting ready to draw my second picture, the length needs to be 9 units. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. This is what that looks like blown up 3 times with a scale of 3. Okay? Now, I want you to take some time and do the bottom, but I am going to change it up a little bit since we're running out of space. I want you to use a scale of 2 instead of 3. Okay? So, once you get here, I want you to show me what that looks like. Recreate your picture. If you need to turn it and slant it this way, you can. And when you're finished, get it checked by me. And then you'll be ready to move on to the next task. See ya.